Hey everybody, welcome to Android. My name is Professor Jensen, and I'm really excited to spend the next 16 weeks with you guys teaching you about what is probably one of my favorite topics in this world, Android development. You guys will find out throughout this semester I'm a pretty big Android nerd, and I'm really excited to share Android with you. Before we get started though into content for this week, I wanted to take just a minute and walk you through make sure you're all on the same page, ready to get going this semester. First off, when you first come to our course homepage, you'll see everything's broken down into modules. First module we'll have here, you'll need to start here. I've got a document here to kind of help you get started, as well as another document that's got some links to some Android resources. Especially at the bottom of this particular link here, there is an Android development textbook. Now, I want to note we are not requiring a textbook this semester. The honest reason behind that is textbooks, by the time they're published, are so far out of date because Android's evolving way too quickly, and the turnaround time for textbooks is too slow, that you'd be learning information that's several years old. This textbook's not expensive. It's $20, and that gives you access to it for 6 months. It has great tutorials. It's even got a handful of different videos. The guy calls them Appenars. His name's Mark Murphy. He's a well-known Android developer around the country that provides this textbook. It's updated continually, and you'll find that it'll even update throughout the middle of the semester, which is part of what his goal and his mission is with an ebook here. So if you're interested, this $20 textbook here may be worth your time, but I'm not going to require it by any means. Also, to get us started off this first week, we're going to have introductions. So take a minute and introduce yourselves to each of us if you haven't already done so. And then every week after this will be broken down, kind of like you see here. We'll have our topics. We'll be able to see some resources, which will be links to important things that you should know. A discussion post, this video and other videos as necessary, and then any particular assignments or things that are due from you will show up under this week 1 requirements or week 2 or whatever the requirements are. Such as this week, we have a short survey that I would like you to fill out, and then your first Android assignment. Now this assignment is going to be pretty simple. It's really mostly there to make sure that everybody's got an IDE up and running and an emulator or a physical device, one of the two, to be able to get going on. Make sure we have all those bugs ironed out, because we're going to hit the ground running and running pretty hard next week. We've got a lot of ground to cover. But if your experience is anything like those that have taken this class from me in the past, they've absolutely loved it. It'll push you, but we're going to learn a lot, and hopefully by the end you'll have an application that you'll be able to someday put into a portfolio or even put on the Play Store, maybe make a little bit of money, which is okay too. And then lastly, in each of these weekly modules, we have our week 1 learning objectives. Now each of these little objectives will help you kind of have an idea of what's the important tasks that are coming out of this week. So for example, this week we're focusing on understanding the Android environment, setting up an environment, how to set up studio projects in Android Studio, the basic structure and navigation. You'll need to know how to navigate the IDE, how to take some screenshots, because you're going to need that to turn in your assignment, as well as how do we start laying out a UI. Because Android is so focused heavily on UI, this may be one of the first classes where you're really going to put a lot of effort and a lot of attention into how a UI is designed and how do the logic and the UI elements come together. But before we dive into all of that stuff, I wanted to take just a couple of minutes and give us a quick brief overview of Android and what that means. So for example, the first question to kind of think about is, where do you find Android? Well, there's the most obvious ones as a phone or a tablet. You're even starting to see them now a little bit like with notebooks via Chrome OS, or even on laptops or desktops you can run Chrome or Android applications via Chrome. Perhaps a little less commonly you'll start to see Android on things such as, like maybe TV or watches, even infotainment systems in, say, airplanes or cars are common places that's starting to evolve a little bit. For Android, I guess I should put the phone and tablet. Those are the two big ones where we find Android most frequently. One of the big things, though, to think about, and the reason why this stuff matters, is if you think about it, a phone, you got maybe a 4-inch phone, or maybe you're rocking the phablet like me and you've got a 6-inch phone. Maybe you got a 9 or 10-inch tablet, or you got a 40 or a 50 or even a 60, 70-inch television. All of these things running the same applications. And part of the Android paradigm is that we can write an application once for something in specific and not have to spend a ton of time continually rewriting it. I don't want to have to write an application specifically for a phone or specifically for a tablet and then write it again to function on a TV or a watch. We want to be able to package an application once and have it run anywhere. It's that paradigm of write once, run anywhere, or run many places, so that we can develop an application once and then we can push it out to whatever form factor it takes. Now, if you think about it, you guys have probably experienced some of that already in CS2350 because the internet functions along similar paradigms. It can be running on a person's phone or a tablet, it can be running on desktop, it could be running on television, it could be running on a jumbotron in a stadium. But in all of those cases, we want to be able to publish and get our applications running smoothly in each of those screens. And we want the application to adjust and adapt to each of those situations. So because of this, Android focuses on things a little bit differently than, say, other languages you've encountered. First and foremost, with Android, we're going to focus on screen sizes, but we also bring in now screen density. Because it is very possible that, helps if I spell properly, very possible that we may have an application that is running on a phone that is actually larger pixel size, even though it may be less physical size than a television, for example, which is this area of density. And we'll talk about that a little bit more. But even beyond that, okay, if we can focus on those two sides, but even beyond those, Android really puts a lot of effort in caring about capabilities and features. Rather than on where it is running, we worry about, how much real estate do we have to work with as a function of these two pieces, and then what is the thing that I'm running on capable of doing? Can it send a text message? Can it access the internet? Does it have a touch screen? Does it have a physical keyboard? Does it have a mouse? All of those different things come into play for us, so Android will then make decisions. If we code to these capabilities and features, the operating system will take care of the work for us, so our application runs smoothly on all of these situations. We don't have to worry about it. We just let the operating system deal with those by focusing first and foremost on capabilities and features, then on screen sizes and screen densities. Now, one of the big places we're going to start to see big differences in some of these capabilities and features is not just in the hardware. We'll also begin to see this in the operating system itself. And to be perfectly honest with you, this is probably Android's Achilles heel in some ways too. But Google is frequently releasing new versions, typically one major version a year. Usually released, the final release is somewhere around in October, but you'll start to see developer previews earlier than that in the year, January, March, May. Even a release candidate was just recently released for developers to play with now for the next version of Android. But those Android versions of the operating system will start to bring in those capabilities and features. So we have to consider the OS version, because newer devices obviously will run these newer versions, but older devices may or may not be updated, and especially not for some particular time. Looking at you, Samsung. Just in case you don't know, Samsung takes on average about 18 months to 2 years, which means when they release a new version, sometimes they have to leapfrog over 1 or 2 versions because they took so long to update. Otherwise, they'd be just releasing updates to stuff that's really, really old. So we have to be aware of those things. In fact, Android has a really good tool. You can kind of see if you're interested. Probably should have pulled this up before I started recording, but developer dashboard. Okay, where you can see different penetration of the different versions of Android. Okay, now Android versions, there's 2 things that you're going to care about with these, and they're going to be important things for you to know. First off is the Android version. This is what tells you, like I'm version 2.3, I'm version 8.0, the next one may be 9, who knows, we'll see what it is when they finally release it. Each version also has a code name, which they release to the public, and which, to be honest, the operating system kind of becomes known as for forever. And then the part, though, that matters most to you are these two areas here, okay? First off, the API version is going to dictate what capabilities the operating system has, okay? We want to support a reasonable amount of older devices, or sometimes you have a particular feature that you need to incorporate, and you'll pick an API that's the lowest that supports your need so that you get the largest degree of devices that are capable of running it. For example, as of today when this video is recorded, Oreo has a 0.5% in API version 27, versus if you go back a handful of API versions, you can get in a Nougat and Marshmallow that combined give you basically 50% penetration just with those two, and then you can add those on as well. But the API version is what you're going to deal with in code. That's what's going to dictate. Every time Google changes or adds a capability, sometimes deprecates a capability in the operating system, they indicate that by a running number. This is just ticks up each time, is an incrementing number, this API number, which then eventually ties into versions and code names over there. But the API is the bigger number to pay attention to. Now, because we want to target a reasonable chunk of devices, make sure you're learning, pretty relevant information. When you do your homework assignments this semester, I'd like you to focus on API version 21 is what we are going to target. Okay. Now we are going to target this, meaning this is what we want the minimum of it to be able to run on, but we will compile with the latest stuff. That'll give us the most efficient code, but we're going to target backwards. If you're a developer or a gamer, we're dealing with backwards compatibility here. Okay. We may be writing this on the latest version of the Xbox, but we really want to go backwards a couple of levels as well, and provide the ability for the greatest spread of users to use our application, which is important, especially if you're selling or marketing this. You want to get it in the hands of a lot of people, and one of the key things you can do is targeting backwards. However, if you go far enough back, then the application is hindered somewhat because you're missing out on a lot of common new features. So it really becomes a balance by looking at what it is you want to accomplish, and how reasonably you can go high in the API version you can go in current distributions. These are changing regularly. You can see a little graph here if you're interested. Is this? They usually update this once a month or so, to kind of give you an update and give you a feel of where they are. We can also get an idea on those screen sizes now. So rather than focusing on particular resolutions, we will worry about screen sizes such as small, normal, large, extra large, and then we deal with things now in densities from low density to XX, high density. This is going to be really dense things such as a high density tablet that also has a large physical screen, or maybe one of a newer phablet would land, maybe an XHDPI or XXHDPI. Now I do want to note that acronym there is really important, is DPI. Okay, or what you'll commonly see when we get into code is we'll refer to things in DPs, or density pixels. Okay. Rather than DPI now is dealing with, how many, or sometimes you'll even see in industry people use the term PPI, which is pixels per inch versus dots per inch. The industry uses them pretty interchangeably. They're not quite 100% analogous, but a lot of people tend to use them that way, so be prepared so you hear both of those forms. But the real term we're going to care about is in DP. That'll allow us to provide a measurement that's independent of the density of the screen. I may have a tablet that puts 400 pixels in an inch of screen space, and I may have a television that's got maybe 130 pixels in that same inch. By targeting into these DP or our density pixels, meaning worry about it in a common unit of measure. That way, the density of the individual device that it may be running on at that point in time doesn't really come into factor quite as heavily. This allows us to perform or to create much more flexible layouts, a lot like you're used to dealing with on the web. for example. Okay, now the next thing I want to take just a minute and talk about is how Android itself works, because this is going to be a key thing for how an Android application works, how devices run, the operating system, how do they all factor in together. Now, if we were to draw a diagram, in fact, let's start down here at the very bottom, okay? On our lowest particular level, now obviously down here is hardware, okay, because we're focusing on the software stack. So the lowest level, the thing that gets closest to the hardware, is we are going to find the Linux kernel, okay? Android is written to run on the Linux kernel, and that kernel is responsible for a lot of things, such as like the display, actuating the camera apertures, Wi-Fi, audios, IPCs, inter-process communication, flash, your flash on your camera, different things like that. Anything that requires direct communication to the hardware, the kernel will take care of. Now, because there's such a huge variety of devices that our Android is running on, like we saw just a minute ago, we want to be able to target our applications to something other than the hardware, because then we would have to support all that hardware in specific, which the kernel provides that capability. But even that targeting the particular kernel becomes a little bit more cumbersome as well, because there's different versions of the kernel that are going to come into play. So when we write applications, we're actually not even going to target up quite that high. Running on top of the kernel, there are two layers that kind of run together. First off, there are low-level libraries and the runtime itself. Okay. Now, low-level libraries are going to provide things such as SSL, maybe OpenGL if you're into games. You'll deal with some of that stuff. Databases, we use SQLite, and those libraries are going to be written to speak specifically to the kernel. Okay, frequently written in something like C or C++, something that's a real high-speed language that can be compiled to the specific kernel to run on a particular set of hardware. Now, the runtime itself, there are two different runtimes in Android. Okay, the first one, we have the ART, or ART, stands for Android Runtime, okay, which is the current Android runtime. Anything that's Android version 5.0 and above is going to use the ART runtime. Prior to the Android runtime, we used the Davalik runtime, okay? That was anything Android 5.0 below. Really what these two things boil down to is they are virtual machines. Okay, when we run our applications, which is going to be a layer right up here, here's our apps, okay? The thing that's going to be doing the real work is going to be the runtime itself. And then the runtime will communicate with the kernel, and it may communicate back and forth with libraries as needed, and they can also communicate to the kernel. But when you think of Android, when you think of the operating system, when you think of the paradigms, when you think of all those experiences you have with Android, this is really one of the key things you're thinking of is the runtime that makes it all possible. But on top of the runtime, there's one other element. You can see our big gap we left that we need to talk about. Okay, this middle gap is our application framework. Together, the framework and the runtime, all together, both of these are what you guys would really call Android. The framework is going to be the things that are going to provide the ability to write activities, to do fragments, to deal with windowing or packaging applications, handling launching, memory cleanup, dealing with all of those elements of what makes an application run. This framework provides those elements. This framework is designed specifically to function on the Android runtime using the libraries provided as part of the OS. When you install a new version of Android, you're installing from the application framework level down, typically. Those are all encapsulated together, and they're designed to run together. Apps are the things you're going to write, such as your browser, maybe a game, Gmail, calendar, contacts, even the phone or text messaging applications. All of those are apps, which you can sideload, but the majority of those you'll find, for example, you'll download from Google Play. If you've got an official Android device, that's the source of distribution. So when we write apps, we're going to focus heavily on how this level works and how it interacts with the framework. How do we make an application successful? We'll get a little bit to the libraries, and we'll talk about some idiosyncrasies of dealing with the runtime. But really, I want to focus heavily in this class of how do we write apps, which is dealing with levels. If we were to number these, levels 1 and 2. We'll level those, okay? That's where our applications live, is you're going to write code, and sometimes you'll write even extensions or changes to the framework. Android itself is open source, so if you want to go see how something works, you can go pull it up on GitHub if you look for the Android open source project. Now, when we write applications in Android, this semester we are going to be using Java. There are 2 languages officially supported by Google. We have Java, or you can also do Kotlin. Now, Kotlin is a relatively new player on the scene. It's been officially supported by Google by not quite a year here. It was released in May of 17 as an official option. It was unofficially supported for several years before that. So the industry is still by and large using Java, which is where we are going to be, because I want to prepare you guys to be able to go out and get a job. And if you understand the concepts in Java, transitioning to Kotlin is just it's a syntax adjustment. It's perhaps a little bit simpler in some areas and a little bit more complicated in others. But if you really know what you're doing and thinking and how to think in terms of Android, in a Java world, switching over to Kotlin is no big deal, and you'll deal with that later on down in your career. So we're going to be writing applications in Java. So what will happen is we'll write an application in Java utilizing Java source code and XML files to handle layouts. We can also provide other resources, such as pictures or sounds or other things like that. All of that will be packaged together. When we compile our code, our Java bytecode and our XML and all of those things are packaged together in an APK file, which essentially, in fact, you can go rename it if you get your hands on one. It's a zip file. The Android package file contains the bytecode necessary for the runtime, or our virtual machine, to run our application, as well as any other necessary resources such as XML files to represent layouts and strings and other things like that, or images, whatever else is necessary for our virtual machine to run our application. Okay. One of the other big things that sometimes trips students up a little bit is you're so used to writing Java in the way you wrote it in your lower division courses. So we're not going to be writing in the traditional Java style no more. If you think about it, and what I mean by that is the first thing you did in any Java application you ever wrote in the past was you started by writing out a public static void main string args function that was your entry point. Android doesn't revolve around that. Rather, Android is going to force you to use object-oriented principles that you've been taught throughout your education and you may or may not use, especially if you're working in industry. You probably have a little bit more experience. If you don't panic. We'll guide you through it. Okay. Instead, we're going to be based on inheritance very heavily, and inheritance, encapsulation, polymorphism, all of those key topics you've heard talked about in other classes. Android is going to be a great place for you to experience that rubber hitting the road. Okay, so when we write applications, there are several basic components, and we're going to use these components because they're going to provide this inheritance chain for our application to run. At the most broad level of an application, we have an activity. Okay, an activity is an Android component that the operating system or the virtual machine knows how to work with, that allows it to handle displaying things on the screen, rendering, if audio, network communications, anything that needs to happen for your application. At the lowest level, those will take place in an activity. So when you write an activity or an application, rather than doing a public static void main, you will define an activity and extend it from the parent activity or app-compat activity if you're wanting to target backwards. Okay? And when you target this parent class, we'll then extend from it in our child class to then be able to get all of the abilities of how the operating system knows how to work with an activity, but everything also that makes your app unique will take place here. Okay? Other components that you'll see in Android, then these are just to plant the names in your head really more than anything. We'll get into them in more depth as the semester progresses. Things such as services. We'll talk about these. We may or may not get time to write them just because there's a lot of ground we could cover with Android. In reality, I would probably need 2 or 3 semesters to really cover everything. So we're going to get the biggest pieces of what industry feels like you need to know coming from me, so that you're ready to get out there and hit the ground running. Other concepts that you'll see besides services are going to be, again, things such as like a content provider, which allows you to publish the information your application knows how to speak so that other applications can consume it. For example, your contacts are maintained by an application on your device, but you can also interface with those through several other applications. For example, you can pick contacts from Gmail, even though the contacts themselves are managed by a separate application on the device. That happens through content providers. We can deal with things such as a broadcast receivers, which couples together with these. We're going to also, one of the biggest things though we're going to spend a lot of time in now besides activities, and the thing that's going to make activities, wow, I just noticed I didn't spell that. Wow, that was terrible. Too bad that was recorded. But one of the biggest things you're going to spend time dealing with are going to be widgets. Now, widgets are going to be discrete fundamental pieces of UI, such as a text view, an image view, a recycler, and they range from really simple things like a text view to really complex things such as recycler views. And even beyond that in terms of complexities. But we're going to deal a lot with widgets when we handle with layout elements. One of the other key things, there's 2 others that you need to know, okay, that we're going to be working with heavily this semester. The other one is going to be resources. Because remember, Android works in terms of capabilities and features. Resources are a key aspect of our capabilities. For example, if I want to put some text on the screen, I'm going to use a string resource to put that text out there, or to handle layouts, or to provide set of default values, or draw things we want to draw on the screen, such as images or sound files or all those other things. Those all together come as resources, and we're going to package them as resources. Especially with strings, this is important because if I put all of my strings together in one place, it becomes very easy to localize my application, meaning translate it. So it can run natively in English, it can run in Spanish, Italian, Chinese, German, French, Portuguese, it doesn't matter. The operating system will take care of all of the work for you. You simply need to give it the resources in the different languages, and the application will take over, or the operating system will take over and make sure that the user gets the experience. Okay, because Android's designed with that in mind, that as a developer, you write something once and let the operating system do all of the hard, confusing, complicated work that you typically had to deal with. Now, the last thing we're going to have to deal with in here, and we'll look at some examples of this in the next video, is our manifests. Manifests. Wow, I cannot spell the day. Are files that are going to allow us to define, for example, what activities are found in an application, what permissions does the application need, do we have any services we provide, or content providers, or broadcast receivers. Essentially, the manifest explains the configuration of your application to the virtual machine. So I may have an application, for example, that has, say, 10 activities. The virtual machine will know which activity to run because the manifest will say start here. It will essentially provide the entry point, much like public static void main did. Manifest will describe what that entry point should look like so that the rest of the operating system can take over from there. Okay, now this first video is starting to get a little bit long, so we're gonna end here, and we'll pick up in part 2, where we're gonna walk through the anatomy of the IDE and getting your first project up and running. Thanks.